All right, so good morning, guys, and thank you so much for joining our grade one roadmap seminar for fourth form chemistry. And I am Miss Smith. Now, the purpose of having the roadmap seminars, let me just tell you about extra time tutoring. We are an institution that has been around for the last 10 years, and our primary focus is to tutor students in chemistry and biology, fourth form, fifth form, sixth form, and to prepare students for the CXC CAPE exams. And our aim is not only to just have you pass the exam. We are really geared towards students who want to achieve a distinction because you want to be competitive, whether it is in discipline that you want to enter and you need a competitive score. So our aim is to prepare students who want to master the subject and score distinctions, or even not only to score distinctions, but to find yourself on the merit list in Jamaica, which every year in CXC, the top 100 students are placed on a merit list and awarded in Jamaica. And even more than that, to be amongst the top in the Caribbean. So that's really what we want for the students. And what we have found is that for our students that have actually found themselves on the merit list and have been found amongst the top in the Caribbean, one of the important things is that we need to teach you or prepare you even before we start teaching you the actual subject. And in preparation, the first thing is to ensure that you understand why you're studying chemistry, how it's applicable, what exactly is the scope of work you have to do in the next 2 years in studying CXC chemistry. How should you approach it? What speed should you be moving at? You won't know all of this unless you understand the entire body of what you have in front of you to do, which is what I aim to do today by walking you through the syllabus and by teaching you what are the topics that you should cover in grade 10, and then what are the topics you'll go on to cover in grade 11. And essentially about your labs as well, and also at what pace, what speed should you be working at if you really want to complete the syllabus in a timely manner and be able to review the content. All right, so what exactly is chemistry? Chemistry is the branch of science concerned with the substances of which matter is composed. So matter is everything that has mass and that has everything that has mass essentially, which includes solids, liquids, and gases. And so we are studying the non-living components of the environment, and we are learning about the properties of and reactions of matter and the use of matter in forming new substances. Why do we study chemistry? I have this video I want you to see as to why we study chemistry.
The world is currently facing some major challenges: protecting the environment, developing sustainable energy, maintaining public health, securing food and water supplies. Chemistry is the central science, the science concerned with all physical matter. We need creative chemists to find solutions.
Take climate change, the biggest challenge to human and ecological survival. Chemists strive to gain the knowledge needed to protect our planet. They observe the subtle changes in the environment, like ocean acidification, atmospheric pollution, and buildup of marine plastics. Chemists at the University of Plymouth are at the forefront of research in this area, informing policymakers on how to protect our futures. They are not just in the lab, they are found working in extreme environments across the Earth, from the tropics to the remote deep oceans and the frozen polar regions. We know that sustainable supplies of energy are needed to replace our reliance on fossil fuels. Chemists at Plymouth create chemical models to innovate industrial processes. They work with nuclear reactors and develop catalysts that can recycle waste into new materials and energy. Chemists collaborate with industry to help businesses improve their operations on a local and global scale.
At Plymouth, I'm working with a team that care about these issues. I'm learning the hands-on techniques that industry and employers seek. I want a degree and a career that support change. I believe that together we are the innovators of the future. Find out more about our courses.
All right, so basically, guys, I wanted you to see this video because I wanted you to understand that chemistry was not just confined to something that, oh, you have it in your textbooks and in your lab. I wanted you to understand that you are being prepared as scientists to solve real world challenges. And so by learning this content now, it is preparing you to be one of those scientists that will be able to solve some of these issues that we have. And some of what he mentioned was that there are several questions that the world has right now, which is that we need to develop sustainable energy. And right now, you are being equipped with the knowledge in chemistry and in physics to be able to be the persons in the next 10, 20 years who can actually offer the solutions for sustainable energy. We also want to be able to secure food and water supplies. Chemistry will give you the knowledge as how to deal with water pollution, how to purify water. Food chemistry is also there for us to have sustainable food and water supplies. Chemistry is equipping you to do that, chemistry and physics. So for you to be able to do these, guys, you must understand matter, the composition of matter, how matter operates, the functions, and predict its properties. And that's why you are learning chemistry. I don't want you to just think, oh my God, I've been given this subject and I have to do it in CXC. No, I want you to understand that you're being equipped with information and knowledge to have be able to give future solutions. All right. So you would be here in the next 10, 15 years, observing the environment and observing how matter operates in the environment, being able to predict it and being able to manipulate it. All right. So I just want you to understand that chemistry is more than just this thing you're studying in a book. Now, the CXC syllabus has 3 sections. There is section A, B, and C. So we have principles of chemistry in section A. We have organic chemistry in section B. And in section C, there is inorganic chemistry. So principles of chemistry, organic chemistry, and inorganic chemistry. You must complete all 3 sections before sitting the exam. Section A gives you an introduction into the fundamental chemical concepts and principles. It allows you to study the nature of matter, the structure of matter, how matter bonds together, chemical properties and physical properties of elements, compounds, mixtures, etc. But this first section is really to get you into the fundamentals of chemistry. Now, guys, I want to stop and say something to you at this point, that in my estimation, chemistry is the most challenging of the 3 sciences. Chemistry is the most challenging of the 3 sciences. More challenging, I believe, than physics. Why? Not that the topics in physics are not difficult or not more challenging. But what I found is that in physics, the topics are not necessarily interrelated. So if you're studying movement and you're studying kinetic energy and all of that, it has nothing to do with electricity, right? Because in physics, you have different topics. So you're learning a bunch of different topics that are not necessarily interrelated. But chemistry is a different thing. Chemistry is like you're building on blocks. So you are learning the foundational principles of chemistry because you need that in order to understand organic chemistry. You need to understand the principles of chemistry in order to understand inorganic chemistry. So then this is where the problem comes for chemistry. If by the time I get somebody in 5th form and that person in 5th form had not learned the principles of chemistry properly, they cannot do organic chemistry very well. They cannot do inorganic chemistry. So we find that we have to be rehabilitating students because the principles were not laid. And so I want you to understand that you cannot do the other 2 areas. You cannot do section B or section C if you did not understand section A. And so with that in mind, you have to zone in because every topic that you learn in chemistry is helping you to learn the other topics that are coming. So when you learn states of matter, which is the first topic in section A, you need to understand states of matter in order to understand mixtures and separation. Then you learn atomic structure. You have to understand atomic structure in order to understand the periodic table and periodicity. If you don't understand atomic structure and periodic table, you can't understand structure and bonding. You need to understand these to the mole concept. Well, mole concept is kind of like a standalone topic. Not really, because you still need to understand these before. You need to understand mole concept in order to progress to acid, bases, and salts. And you can't understand oxidation and reduction unless you understood all of these that came before. So chemistry is the unique one in that it's really a puzzle you're solving. And so you're giving the information in one bite at a time. And you're given the most basic information first so you can understand the next one, that you can understand the next one, and you can understand the next one. So if you come to me and I meet you in grade 11. And a lot of times in grade 11, for the grade 11 class, we start off at oxidation and reduction because we are assuming that in grade 10, you'd have done these other 7 topics. But I guarantee you, if your foundation was shaky from atomic structure, everything else is going to topple down from there. If you did not master atomic structure, you never mastered atomic structure, the periodic table, and structure of and bonding, everything else in chemistry is going to fall over. And that's why I'm stressing this to you. These 3 topics here, 3, 4, and 5, critical. Everything else, you cannot do section B. You can't understand it. You can't understand section C if you didn't get these first 3 topics. So I want you to see that chemistry is a puzzle. It's not discrete. So you have to zone in for each topic, all right? So topics in section A include states of matter, mixture and separation, atomic structure, periodic table and periodicity, structure and bonding, mole concept, acid, bases, and salts, oxidation and reduction, right? However, guys, we're going to stop at, usually you end at acid, bases, and salts in grade 10. Some schools go on to do oxidation and reduction in grade 10. But when you go into grade 11, you're going to complete section A in grade 11, which includes electrochemistry, rates of reactions, energetics. Now, the topics you must cover in grade 10 are states of matter, mixtures and separation, atomic structure, periodic table and periodicity, structure and bonding, mole concept, acid, bases, and salt, and oxidation and reduction reactions. Then you cover in grade 11 the rest of section A, section B, and section C. So you see that grade 10 is not necessarily going to grade 10 is not bulky for chemistry. It's not bulky, all right? However, it is the foundation upon which you are going to have to learn to understand the remaining topics in section A and B and C. So I want that point to be taken home to you clearly. And I guarantee you, if you get these topics, if you get that atomic structure under your belt, you get that periodic table, and you get the structure and bonding, everything else will fall in place. Everything else is going to fall in place once you get the first, I'd say the first 6 topics in chemistry. You get that solid. In order to get the topics in a very comprehensive way, guys, you have to practice. Meaning that when you learn something, you have to do it yourself. So the way that we do it at Extra Time when we have our students preparing for grade 10 chemistry, when in every class, this is the order of the day. So we teach you the concept, then I demonstrate to you a question, how the knowledge is applied. So make sure we do an example. Then after that, we say, all right, if we've done one example, let's do another one. And then the next time we say, you try one. That third part there of you trying it, that you cannot skip that step. You won't know if you really know something unless you can reproduce it. So when we ask you to try it and you to reproduce it, that is a critical step. And we get the feedback from you to see that you have understood it. Once you see that you have understood it, the next thing is asking you to do a question on it. You say, can you apply what you've learned to a question? Because you've already done an example by yourself. So now you should be able to go forward putting it into a question. And once you put it into a question, it means that you have solidified the topic. So if you find yourself in class and you're learning the topic and you watch the example that the teacher did, but you never did one, you never did an example, and the teacher never looked at you doing one, you never did a question on it, just know that you're going to be in trouble. All right? So I'm stressing that from now. All right, so let me just show you for section A, applications to the everyday life.
Hey, grade sixes, so we are back today, and I'm going to show you 2 things today. I'm going to show you firstly how solids, liquids, and gases are part of our everyday life. And the second thing that I'm going to show you is how we're going to change water from a solid, then a liquid, and then into a gas form. So we're going to show the 3 phases of water here in this video session, and also I'm going to show to you how we use solids, liquids, and gases in our everyday life. Okay, grade sixes. So in our everyday life, we get to use a happy ball, for example. So if I look at that happy ball, it will be a solid on the outside, and I fill the happy ball with some gas on the inside. Here I've got the plate. This plate is filled with sand. So I've got a hard plate, and the sand is also a solid. And then I've got a glass that we drink water from, or cool drink from every day, filled with a liquid inside. The gas will be the glass will be a solid on the outside, and then I've got the bottle of Coke here, liquid on the inside, and, um, and then the hard solid on the outside. Okay, grade sixes. Now I'm going to show you how I put a piece of ice inside of a warm bucket. Can you see that the pot is hot, and that therefore the ice melts immediately, and it forms a liquid. So I've got the ice in the solid form of water, and then I have water as a liquid form. And as you can see now, the water is starting to evaporate. So the water is evaporating in the form of steam. As I see, now I can see slowly but surely the water is evaporating.
All right, so to be able to explain what's happening here, guys, you would have to learn the principles of the states of matter and how we go from one state of matter to the next. Another application of one of the topics you will learn in section A is mixtures and their separations. Let's look at this topic video.
Mixtures are formed by combining two or more materials. Here are the examples of mixtures. Number 1. Salt and water are the compositions of sea water. Number 2. Acetic acid mixed with water produces vinegar. Number 3. Ingredients such as sago, nata de coco, sweet beans, sweet ube, leche flan, ice cream, and milk are blended with crushed ice to make halo-halo. Number 4. Chocolate chips added in cookies produces chocolate chips cookies. Number 5. Sand and seashells are the components of beach sand. Number 6. Iron metal mixed with carbon are used in manufacturing steel bars.
So guys, you're going to learn about various mixtures. You're going to learn about mayonnaise, vinegar. You're going to learn about different ways you can mix matter together. And then, of course, how can you separate them? All right. So then there is atomic structure. And as I already stressed to you, this is one of those pillars of chemistry, the blocks that hold chemistry together, is your knowledge of atomic structure, the periodic table, structure, and bonding. If you master those three, structure and bonding also includes writing equations. But if you get those three under your belt, I guarantee you can do every other topic that comes. If you don't have those three topics under your belt, you're going to struggle for every other topic in chemistry because those three topics, the foundation were not laid properly. Let's look at this video about atomic structure.
Welcome to Moving Math and Science and an atom. Matter is anything that has mass and takes up space. Examples include stars and planets, a dog, and a rubber ducky. Most of the matter in the universe is made up of atoms. A substance that is made up of only one kind of an atom is called an element. You can find all the elements in the periodic table. Each atom is also made up of smaller particles known as subatomic particles. In the nucleus or the middle of an atom are two subatomic particles called the proton and the neutron. The positively charged particles in the nucleus of an atom are called protons. The number of protons in the nucleus is the defining property of an element, and it is referred to as the atomic number. Since each element has a unique number of protons, each element has its own unique atomic number. The uncharged particles in the nucleus are called neutrons. Orbiting the nucleus of an atom is a cloud of negatively charged particles called electrons. The electrons are much, much smaller in mass than protons and neutrons. The mass of an atom is based on the sum of the mass of the protons and neutrons. Thanks for watching. Math uploads.
All right, so this was just giving you a basic introduction, guys, into the atomic structure. All right, the structure of the atom. Of course, you're going to learn greater detail for the atomic structure. And then this other topic that I told you is one of those topics which are critical, is knowledge of this periodic table, which is where we look at all the different substances on the earth, elements, and we have arranged them in a table which makes it easier to study. And this is an interesting video where Bill Gates actually has the periodic table in his house. You can imagine how fascinating this is. He has had a copy of each element and what they are used for in his house. Some of these are extremely dangerous elements, mind you. They are very explosive and poisonous and toxic. So this is not a cheap thing that he has. And it's also, well, of course, for it to be safe, he must have spent a lot of money, but he's one of the world's richest men, so he can do that. But just imagine having each element at your house. But when you learn the periodic table and this table, how it is arranged, then you will be able to predict the properties of elements just based on their position in this table. So you want to learn the atomic structure, you want to learn structure and bonding, and you want to make sure you have the periodic table. Those three things must be deeply entrenched in your system if you intend to succeed as a chemistry student. Then bonding now is where we look at how elements can be joined together, which is by sharing electrons or by donating electrons to each other. And we look at the different types of bonding, being covalent, ionic bonding, and metallic bonding. We'll go into detail with that. And then the other topic, which you're going to spend a good amount of time in fourth form learning, is how to do calculations involving chemistry. Chemistry has its own set of calculations, which is a bit different from just regular mathematics. So it's mathematical, but it also has other rules. So we're going to be learning now how to do this in the mole concept. Let me just go back for a moment. So the mole concept is a specific method utilized in chemistry to do our calculations in chemistry, because in chemistry, we are dealing with things which are invisible to the naked eye. We're dealing with atoms, which the most powerful microscope in the world cannot see an atom. We're dealing with things which, if you made one full stop, if you have one full stop, guys, in your book, right? If you draw a full stop on your paper, there are trillions of atoms in the one full stop. So you can just imagine the size of an atom. Ridiculously small. But yet still you have to calculate something that is ridiculously small. You could not use traditional mathematics for that. So that's why a specific system was designed for chemistry alone. And we look at this, and there's a specific number that we use called the Avogadro's number. And this is how big it is. It's 6.2 times 10 to the 23. And sometimes this is a huge number, and this is the number we use a lot in the mole concept. But of course, you're going to learn about it. And it's like a compound noun. So like, for example, when you say 1 dozen egg, you know that a dozen means 12. So in chemistry, when we say that we have a mole of something, we mean that we have this amount of atoms or this amount of particles of the substance. But because the atom is so small, you can have this large number of atoms, and it still is the size of a full stop. So it's a big number, but it doesn't mean that you're going to be seeing huge objects, because it's made up of these tiny particles. So guys, you have to master the mole concept, because again, the topics which are coming up, Well, basically, you're learning the mole concept to learn the topics that are coming up. So if by the time you get to something like electrolysis, which is in the fifth form, you cannot do electrolysis, guys, if you never learned atomic structure, if you didn't learn structure and bonding, and if you didn't learn the mole concept. So chemistry is just one of those subjects that you have to be in tune from day one, because every topic is equipping you to learn the next topic. That if there's nothing else I can leave with you today, that is what I want to leave with you. You are going to be in trouble if you did not get the fundamentals right. All right. Acid, bases, and salts is another foundational topic, which by the time you get to acid, bases, and salts, if you didn't learn mole concepts before, you're going to have problem here. That's everything. Atomic structure, you're going to have trouble here as well. Let me just play this video for you.
If we are given lemon juice and soap water in two different beakers, will we be able to list the difference between the two? Perhaps the list will begin with the different colors, appearance, and so on. But these are just properties that we can see. Are these the only differences? There are more. Lemon juice tastes very sour. Soap water tastes slightly bitter. Please don't try to taste it. Just trust me, it tastes slightly bitter. Is this a major difference between the two? Yes. Taste is an important parameter as it takes us to the chemical properties. Why does lemon juice taste sour? And why does soap water taste bitter? Any idea? The answer lies in their nature. Lemon juice is an acid while soap is a base. Do you know what an acid is and what a base is? Let's get to know these terms first and later get into the details. To begin with, we have acids. The moment we hear the term acid, something scary or something that would burn the surfaces is what pops up in our mind. Well, that's kind of true, because acids are known to create a burning effect of whatever comes in contact with them. They can erode the surfaces or burn the skin when they come in contact with it. That's how acids are. The term acid comes from the Latin word acidus, which means sour. Yes, so are all acids sour to taste? Yes, they are. The intensity of sourness may vary in different acids, but the overall taste of acids is always sour. The best examples of substances that contain acids include citrus fruits like orange, lemon, lime, and grapes. Now let's talk about the soap water. What nature does it have? It is basic in nature, which means soap is a base, or in other words, an alkali. What do we mean by this? For now, all we need to know is that the mild bitter tasting compound is called a base. Bases, when added to water, give foam and feel soapy when touched. Bases are exactly opposite to acids. The best examples of bases include baking soda, washing soda, quicklime, and many more. This was about acids and bases in general. Now, can you tell me what will happen if an acid and an alkali, as in a base, come together? Will the solution explode? Will it give an unexpected reaction or something else? Well, it is something that we already know. Imagine we mix a strong acid like hydrochloric acid with a strong base like sodium hydroxide. What will be the result then? The reaction yields sodium chloride and water. Sodium chloride is the common salt used by us. So, an acid with a base gives us salt and water. This is a generalized reaction.
All right, guys. So what you're seeing right here is a chemical equation, guys. And why I said to you that you have to be learning the other topics as you go. As I said, the topics are ordered in a specific sequence because they know that you could not understand topic number 7 if you didn't do the previous 6 topics that came before. Because in the previous 6 topics that came before, that's when you're going to learn about the atom, you're going to learn about the periodic table, you're going to learn how to bind or bond elements together to form compounds, because this is hydrochloric acid is a compound, sodium hydroxide is a compound, and sodium chloride is a compound as well. Now you're going to learn how to mix compounds together to create other compounds, and that is a chemical equation. And then you're going to even learn how to calculate how much sodium chloride you can expect to form. That's the mole concept. So everything is building up. And so your knowledge is becoming more and more complex as you go further and further in chemistry. So by the time you get to the level of CXE, as a chemistry student, you have a very highly complex knowledge base. All right. So then, guys, you have your school-based assessment, which is an integral part of your assessment in the course of the syllabus. And you are given experiments because it's to assist you with acquiring certain knowledge, skills, and attitudes, which are critical to the subject. Now, there are suggested practical activities for specific objectives in the syllabus. So there are specific things that CXE will write beside it that they suggest that you do a lab on that specific objective. No, it doesn't mean that you have to do the lab, but it simply means you must know the lab associated, meaning you may have to watch it on YouTube, you may need to read it from a book, but if CXE suggests a lab for a topic, it means you must know that lab, all right? So students are expected to develop the skills that are associated with labs. So this is now your practical component. So CXE says that over the course of the 2 years, guys, you must do a minimum of 16 labs. All right. And some students were here in the biology session, the fourth form biology session. I'm just going to ask for persons who were there. Do you remember how many labs you had to do for biology, the minimum amount of labs you had to do for for CXE biology? Let me just see if anybody remembers. Type it in the chat. Type it in the chat for me. You can type it in general chat because I just want to see how many, if you remember, if it's stuck in your head. Very good. I'm seeing some persons answering and everybody's correct. 18. And I'm telling you, see, if you have this information, you're walking around, guys, you are actually helping to guide your teachers. Make sure that you're on your P's and your Q's. You know why I'm stressing this to you? Because sometimes, unfortunately, you're in a school and sometimes the teacher leaves halfway in the school. I don't know if you've ever had that experience. Sometimes the teacher leaves, sometimes the teacher migrates, sometimes you're getting a teacher halfway in the term. I know I've had students that sometimes the whole year you don't have a teacher. So guess what? Even when the teacher comes, sometimes the teacher doesn't get to finish everything. They're trying to hurry to finish everything. But if you are an aware student and you know what is happening, I'm telling you, that is the first step to getting a distinction. Because you cannot be a student who is lost and get a grade 1 or master a subject. Nobody masters anything in life by not being aware. And that's what I'm trying to make you be aware. All right. So you have to do at least 16. That's the minimum. Of course, some schools will do much more like that than that. Some schools like Camp and Immaculate probably do 25, 28, 27. Because the reality is this, and I don't want you to go in there and say, oh, why am I doing so much labs, guys? That's not why we're doing this. It says a minimum of 16, but if the more labs you can do, the better it is. Because remember, I said to you that CXE tells you a suggested labs. And they might tell you suggested labs are like 30 different objectives. But sometimes you can't do 30. But if your school can do as many of those suggested labs as possible, and you actually saw the lab and actually did the lab, then I guarantee you, if you get that lab on a 60 paper, you can do it. But when you don't do as many labs, if you only do the bare minimum 16, it means that the other labs, you're going to have to imagine them, right? Because you never really did them. But CXE wants you to know them. So then it means that you're going to have to look on YouTube and look at how they're done and how they're interpreting. So I tell you that a lot of schools will give you more than the 16 is because they want you to physically do more labs so you can see them, you remember them more. But just in case, just make sure it's not less than 16. And these are the topics that labs must be done on separation and techniques, must be done on acid bases and salts, must be done on redox chemistry and electrolysis, qualitative analysis, volumetric analysis, rates of reactions, energetics, and this one is from organic chemistry. So these are the core topics that the labs have to be done here. You can do from other topics, but these topics must be done. And then now, over the 2 years now, for grade 10, you're going to be getting a chance to earn up to 60 points. And in grade 11, you have to earn another 70, up to 70 points. At the end of the day, that means that you're going after 130 points for labs. Now, the labs now, there are 4 skills assessed in your labs in chemistry. Manipulation and measurement, that's how well you can actually use the apparatus in the lab. Like if they tell you to measure something, if you know to measure it properly, you know to touch, handle the things in the lab properly. So the teacher will watch you for those labs. So manipulation and measurement is teacher looks at you and gives you the grade. All right. So he or she is looking at how well you conduct yourself. Observation and recording and reporting now, that's when they look at how well you write what took place. If you are writing in proper English, You're writing in the past tense. You're writing in the past passive tense. Like, for example, instead of saying, I poured out 50 mils of acid. No, you can't say that in CXC. You have to say 50 mils of acid was poured out. So those are the things I look for. Did you copy the information properly? Planning and designing is now when we give you a problem and we say, can you design an experiment to solve this problem or to answer the question? And analysis and interpretation now is when you're given like labs or graphical information and you have to interpret it. So CXE wants you to get these four skills from the labs. So you're going to be assessed on them, some of them more than others for year one, and you come and you get assessed on them again in year two. So at the end of it, your teacher will submit your score on this sheet to CXC, for what you scored in each skill in year one and what you scored in each skill in year two, and they send up the total mark to CXC. Now, when you sit the actual CXC exam now, 2 years from now, then when you get your grade, like our students just recently got the grades back. I think it was like the 15th of August or something like that they got by the grades. Then you're going to get the grade and you're going to get the profile for the grade. So you will see 3 profiles. Let me see if I have a copy now. So you're going to be assessed on knowledge and comprehension, how well you use knowledge and your experimental skills. So your knowledge and comprehension is going to be tested in your multiple choice paper. The multiple choice has 60 questions and you're going to be primarily be tested on how well you remember things. That's all it is. Knowledge and comprehension is just remembering things. It's not asking you to really apply any knowledge. Just do you remember? Use of knowledge is application. You're going to get at least 10 questions in the multiple choice on that. Paper 2 now is more heavily testing your use of knowledge, being given bits of information and asked to extrapolate or extract or apply information, knowledge from the information you've been given. And it does test knowledge and comprehension as well. And there is a question on the paper 2 paper that tests your knowledge of experimental skills. All right. And then, of course, you would have had your SBA, which is paper 3, which is your labs. So now, essentially, we're saying that paper 1 is 60 marks, paper 2 is 100, and paper 3, 40. But this is the total raw score, and then they scale it down to 100. But on average, this is how I like you to remember it, that you have the chance to earn 20% from your labs. Not really fully 20 because 10 marks comes from paper 2, but almost 20% of your grade. You can enter the CXC exam with 20% of your grade from your labs. So I would say that if you want to get as much out of this 20% as possible, then going back to the labs here, you want to be getting at least 90% of the 60 marks from year 1 and at least 90% of the 70 marks from year 2. So you can go in with as much as possible out of this 20% in the exam. Then now your multiple choice, knowledge and comprehension is going to contribute 40%, 43% of your grade, and use of knowledge 37% of your grade. So I had some students, like I got some results this year, and we tried, like some students, we really tried to send them in with a good experimental skill grade. But remember that it's not just the labs, you have to answer that question on the paper very well. So some persons went in, they went into the exam with like, so this 70 and 60 adds up to 130, right? And they scored like 120 out of the 130 marks. So they're going in with a good grade. But apparently they went in the exam and did not do this question very well. So CXC demoted them to a B, a grade B for their experimental skills, even though we sent them up with a grade A. And then now, you have students who very well at the lab, but they never really studied for the exam. So they are getting like a profile for use of knowledge. You're getting like C, and knowledge and comprehension is a C. Those students are not going to get past like a grade 3. All right. So it's a profile that's going to tell you what grade you get, right? So if you're the student who wants to get a grade 1, what profiles do you think you need to get a grade 1? And this letter, so they have A, B, C, D for each one. So let me see what you think. So you're going to get 3 letters on your grade slip. What letter profile do you think you need to get a grade 1? Let me see what you think. So it means that, guys, you'd have to get an A in knowledge and comprehension. You'd have to get an A in use of knowledge and an A in experimental skills. Right? So anytime you start getting anything less than an A, it becomes very shaky. You can get a B somewhere. You can get a B in one of these and still get a grade 1. If you get 2 Bs, you're not going to get a 1. You're going to get a 2. If you get 2 Cs, then you get down to a grade 3. All right, so that's how you get 1, 2, and 3 CXC. Comes from the profile. So I suggest, guys, that you go to you dedicate at least 2 hours of your time to studying the subject, at least 2 hours. You have to do questions after every session. Everything you have learned, you must find something to apply it to. But multiple choice, because that's preparing for paper 1, and the essay questions is preparing for paper 2. You want to make sure you're earning no less than 50% of the possible 20% for your labs. Make sure you have a personal copy of your syllabus. Tick off the objectives that were covered each week in the syllabus. And remember, as I was stating before, and this is how CXC lays out the syllabus. This is from section A. So this is under states of matter. So they are giving you objectives that the student must be able to give evidence to support this particular theory of matter. And they give some explanation to guide the teacher. So, well, the student must be able to give evidence from diffusion and osmosis, and how you use salt and sugar to control pests. So they are telling you an application of this knowledge. Then CXC says there is a suggested practical as well. They want the student to do experiments showing the fusion of ammonia and hydrogen chloride in a cylindrical tube. They want also, or they suggest that we can do osmosis with papaw strips in a container of water, or potassium permanganate in water. And they're even going on to suggest what skills you should assess these labs for. So I'm saying to you that this suggested practicals that CXC gives, the teacher may not do these, but the fact that CXC has suggested it, it means that you are to know. So even if you don't do these labs in school, you still have to research them on YouTube. So if you read ahead on the experiments that can be done for an objective, watch YouTube videos to get visual insight to the topics and labs, then guys, you're on your way. So this is, for example, the lab about potassium permanganate that is on YouTube, that you could have watched it yourself. And you could have, therefore, see, even though you never physically did it in the lab, or better yet, if your teacher tells you that you're going to do the lab, go on YouTube and watch it first, so that you are prepped. So when you go in the lab, you know what you're looking out for. Then when it's time to write your discussion, you shouldn't be guessing and spelling, because you can go on YouTube and see somebody who did the lab already and listen how they interpreted it and follow that. So in this age, guys, you have smartphones and stuff, but I don't think you guys are utilizing it as you should. And I don't mean like using Chat GPT to write the lab for you, because then that's taking away the power from your own brain. But I'm like, use the technology that you have available to you, right? So I have a question for you just to see what you remember from what we covered. Let me ask you, do you remember the minimum amount of topics that you really ought to complete in grade 10 chemistry from section A? Let me see if you remember that. Okay. All right, so thank you. I don't know if it's Udia. I'm not sure if I pronounce it properly. Rose Chamoya, thank you very much. I want you to walk away with this in your head. All right, and persons are saying 7 to 8. And let me ask again now. Let me go back to that slide. I want to see if you remember which of the topics I said to you. If you don't, these are the topics, right? And I said some schools will get to number 8, some schools will not. Like in our classes with my students, I usually don't get to number 8 in grade 10. I do that in grade 11, because the truth is this: what I find is that once these 7 topics have been done properly, and my students are competent in these 7 topics, there is nothing I can present in grade 10 that they won't breeze through it. You just fly through it, because All you're doing is just applying the fundamental topics. But of these fundamental topics here in grade 10, which three of them did I say were the foundations of chemistry? Which three topics did I say? You don't have to write out topics, just tell me the numbers. Which three topics did I say? You must master them, or else you're going to be in trouble. Mhm. Thank you for your response. 3, 4, and 5. Number 6 is important too. The mole concept is very critical too. But even the mole concept, you can't do the mole concept if you never mastered 3, 4, and 5, right? So I want you to be conscious of this as you are starting your classes. When you start your classes in the week to come, you have the roadmap in your head, right? That's what I wanted all the chemistry and biology students to have a roadmap in your head. You know where to look for information. You know how to look in your syllabus and interpret it. You know how to assess if you're going at a good enough speed, right? Because you already have a template of what you really should be doing at what point. All right. So guys, that's what we hope to convey to you. Thank you so much for attending. We're really happy that you attended our seminar here at Extra Time Tutoring. And we wish you all the best in your exams. We do have classes, extra classes for persons who need that extra help, for persons in chemistry 4th form, 5th form, and 6th form. So you can join if you need that extra help. Go ahead with the question.
I sent it in the chat, miss.
Oh yeah, no, we don't do physics here, but we do have physics persons that we can recommend. All right, guys. So thank you so much for coming, and I hope you have enjoyed the rest of your day. And if there's anybody who takes you the other topics, I sent you the schedule with everything. So whatever else you may need to attend, feel free to attend. And enjoy the rest of your day, everyone. Bye, guys.
Bye, miss.